Okay, this is section 2.3 from our Math Links 9 textbook. Section 2.3 is operations with rational numbers in fraction form. And we're going to have some exemplars here to help guide you with your questions. And the first two exemplars are simply the addition and sum of rational numbers in fraction form. And the only difference between a question you would have had in grade 8 and a question you have in grade 9 is right here. We're dealing with we're dealing with just negative fractions and positive fractions, similarly to how we would have dealt with them in 2.2 with rational numbers, or in whole number form, positive and negative numbers. So the first question A, we're going to do here together. Negative 3/4. Now, negative 3/4 can be written as either negative 3/4, negative 3/4, or negative 3/4. It doesn't really matter. Given the fact that a negative 3/4 can be written anyway, my recommendation for you is to always write your negative sign in the numerator of your negative fraction. It's just good form, and you'll find that as you get used to it, it's going to make your operations easier because you want that negative number in your numerator because that's where the operations happen. Take away a fifth. Of course, we're going to use common denominators. Between 4 and 5, the first multiple they share is 20. When we do this, we multiply by 5, we multiply by 5, you get negative 15 twentieths. You multiply by 4, you multiply by 4, you get 4 twentieths. And this is the step that most people don't use. I want you to pay attention as you're copying down these notes here. You're going to write this step down. And then once you get really good at it, you're not going to write the step anymore because you're going to be okay. But the rule is to subtract your numerator. So I'm going to write negative 15, take away 4, and you keep your denominator. You have to write this step, and I want everybody in grade 9 to write that. Because if you don't, the tendency is to make mistakes. Because you're taking away a positive 4, that's the same thing as negative 15 plus negative 4 over 20, which means your final answer will be negative 19 twentieths. Now, at this stage in the game, you could also express your answer like that if you wanted to. Or weirdly enough, you could put it in the denominator, which you wouldn't want to do. But that is negative 19 twentieths. Our second exemplar gives us the addition of two mixed fractions. One's a negative mixed fraction, the other's a positive mixed fraction. So when we write this down, I'm actually going to change them both right away to improper fractions. So here's the interesting thing. Some people get tied into saying, okay, I remember back when I learned in grade 5 how to change this. I multiply those two, so 2 times 2 is 4, plus 1 is 5 over 2. They learned that and they're like, perfect, I know how to do this. The problem is, when you get a negative number, some people think that 2 times negative 2 is negative 4, and negative 4 plus 1 is negative 3. So they think that this is the answer because they're following that rule that they learned back in grade 5 or 6. But the only problem is it doesn't work. That doesn't work. You can't do it that way. You actually just have to make this negative, right? Negative 2.5 is still negative 5 over 2. It's the same thing. So you can't use that algorithm verbatim, otherwise you're going to get the wrong answer. So we got to be very careful on that. So when I change negative 2.5 to an improper fraction, it's just negative 5 over 2. Notice how I'm putting the negative sign in my numerator. Plus 1 and 9/10 as an improper fraction is 19/10. Second step, common denominator will be 10. First multiple of the share. 19/10 shan't change. But this is going to become negative 25/10. Now, just like exemplar number or letter A, we are going to write this next step. We're going to add the numerators, and I'm going to write it down, just like that, and keep the denominator. Negative 25 plus 19, I have more negatives than positives, is negative 6. My answer is negative 6/10, which will make any math teacher head explode if you leave it as a non-lowest term fraction, even though it's right. Reduce it to lowest terms by dividing both by 2, and you get negative 3/5. That's your final answer. So really, yeah, that yellow highlighted step is just the only one that's really in addition to your thinking. You got to write that down, and then everything else is going to kind of fall into place as long as you're okay with it. All right, second set of exemplars are now the multiplication and division of fractions in both positive and negative fractions or rational numbers. When we have this, some people are like, even in grade 9, they're like, I don't know what that says. But most of us now know that that says negative 2/5 multiplied by negative 1/6. Right, that's what it says. When we have the multiplication of two fractions, you can cross-reduce or you don't have to cross-reduce. If you're not a cross-reducer, don't worry about it. It's going to make your life a little bit more difficult later on, but it's not the end of the world. Remember this negative sign right here is in the numerator. So I'm going to erase that just there. Make sure I put it in the numerator because I like it there better. When you multiply your numerators, you're going to get negative 2 times negative 1 over 5 times 6, which is going to end up being a positive 2 over 30. In lowest terms, it's going to be a positive 1/15. Right? That's if you did not cross-reduce. But only banana heads don't cross-reduce when they're multiplying two fractions because it makes your life easier. A negative 2 over 3, or just 2 over 6, is going to become a negative 1 over 3. And the reason why we would want to do that is now when we multiply the numerators, a negative 1 times a negative 1 is a positive 1. A positive 5 times a 3 is a 15. So we end up with the same answer of 1/15. We just had to skip that whole tedious reduction of a regular fraction. But half a pound of one, 227 grams of the other. What difference does it make? Okay. And your second question in your exemplar is simply a division of two fractions. Change them both to improper. So 8 times 2 is 16 plus 1 is 17. So negative 17/8, negative sign in your numerator. Divided by 4 times 1 is 4 plus 1 is 5 over 4. Of course, we're dividing fractions, which we said in the warm-up is easierly accomplished by multiplying by the reciprocal. Only banana heads. Cross reduction is the best course of action. If you do it, you get 1 over 2. And then you end up with negative 17 over 10. But we'll pretend you're not very smart. And you didn't do that. And then you just said, well, what's negative 17 times 4? That's 34. 68. Negative 68 over 40, which is negative 1 and 28/40, which is negative 1 and 14/20, which is negative 1 and 7/10. Right? If you reduce it like that. But if you cross-reduce, look how much easier life is. Seriously, look at this. Look at that. You get negative 17/10 right away. Boom. Which is negative 1 and 7/10. Cross-reduction. It's the way of the future. And the last two questions for exemplars we have are actually story problems. And the reason why we're using story problems as exemplars is you are going to use these. And the way I show you how to do your work is kind of a habit you should get into showing your work. The first exemplar utilizing fractions says at the start of the week, Maka, don't know what nationality Maka's name's from, but Maka's kind of a neat name, had $30 of her monthly allowance left. First of all, I don't know anyone that gets monthly allowances. And second of all, $30 left of a monthly allowance seems like an awful lot of money. That week that she only had $30 left, she spent a fifth of the money on bus fares, another half on shopping, and a quarter on snacks. How much did she have left at the end of the week? So for this particular question, organization of your work is important. So the first thing we're going to do is put bus here, and we're going to put a fifth of $30. That's what she spent. She spent a fifth of $30 left on her on bus fares. Now, if we translate this into mathematics, a fifth of 30 is going to be the multiplication of a fraction by a whole number. When we do that, we really want to consider that whole number to be over 1. I think I might have said this already. Multiplication of two fractions is best accomplished when reducing a fraction to lowest terms by cross-reducing. If you did that, how much money did she spend on bus fares? She spent $6. If you didn't, you got 30 over 5, which is still going to give you 6, but it's a beautiful way to do it if you did that. So she spent $6 on bus fares. The next thing we're going to put down here is her shopping. She spent 1/2 of the $30 on shopping, or 1/2 of 30, or I think we all know that without doing fraction work, 1/2 of 30 is just $15. So whatever she bought with her allowance, she spent $15 shopping. And finally, snacks. We have a quarter on snacks. So we have a quarter of the $30. Probably do it in our head. Quarter of 30. Well, since half of 30 is 15, then half is what a quarter is. So half of $15 should it end up working out to be $7.50, shouldn't it? If we're using logic. But if we work this out, 30 over 1, cross reduce, 15 over 2. 15 over 2 will reduce down to 7 and 1/2, which in terms of dollars is $7.50. Our final step in the organization of this work is to figure out what she did spend. So she put $6 plus $15 plus $7.50, $28.50 is what she spent. Right? She spent $28.50. And the final step is $30, take away $28.50, means that poor Mackie only has $1.50 left in her pocket at the end of her spending spree. Now the question is there a more concise way to write this? And there is, actually. So I'm going to erase all of this. I'm going to show you the more concise way. And if you can do it, great. If you can't, don't worry about it. If we think about fractions that she spent a fifth on that, and she spent half on another thing, and she spent a quarter on another thing, right? So that's the fraction of all the money. The sum of the fractions is going to be, that's how much she spent fraction-wise of all of her allowance, of the $30, right? So if we think of it as the sum of fractions, a fifth of the 30, a half of the 30, and a quarter of the 30, we can actually add those three fractions together first. What's our common denominator going to be? 20. So we got 4/20ths, we got 10/20ths, and we got 5/20ths, which means she spent 19/20ths of the $30. Agreed? I hope to God this works out. In my head it worked out. We'll cross reduce this. We're going to get 3 over 2. 19 times 3, 27 plus 30 is 57. 57 over 2 is going to be, what's 57 divided in half? 29? No, 28. 28.5. So therefore, we figured out that she spent $28.50, and therefore, since she had $30, that means she has $1.50 left over. This is a great exercise in bed mass construction. And for those students who are pretty good at math, that's where you need to try and get your mind to kind of go. The whole other thing we did before is perfect, no problem. But for the academic mind, kind of concisely articulating what this looks like as a math problem is more important. How much time do we have left in class? 3 minutes? Yeah? Last question. Stefano had $46 in his bank account. I'll tell you what, I'll make a separate video for this question because I think I'm going to run out of time before I finish it. So I'll do one more video after on this one.